right, welcome to lesson 7 of module 1. Today we're going to be learning about what scientific notation is, how we use it, and we're going to be writing some really big numbers and really small numbers in scientific notation. Let's go ahead and jump right into it on the next slide. All right, here's your background information / new vocabulary information. So scientific notation, this is a way to represent very, very big and very, very small numbers using exponents. So for example, if I have this huge number, let's just write 8, 7, 6, 5, 4, 3, 2, 1, 0.923, okay? And we're working with this huge number. We can rewrite this number as 8.765432193 times 10 to the, well, I move this back 1, 2, 3, 4, 5, 6, 7 spaces, so 10 to the 7th. And then when we would use this and work with this number in math, it would be a lot easier because it's just an 8 point something rather than this very, very large number. We can also do this with very small numbers. So for example, if I have 0.8765431, this is the same as saying 8.7654321 times 10 to the, well, I move this back one space, negative first power. And so we're going to do this today. Really, really large numbers like this, the ones I just showed you in green, are going to have positive exponents of 10. So you'll see that this is times 10 to the 7th power. And really, really small numbers are going to have negative exponents of 10. You'll see this is times 10 to the negative first because I moved my decimal back one. Okay, but we'll get into this and how we do it on the next coming slides. Make sure you have this down before we move on. All right, we're going to jump right into this. So the first example is this number right up top. This is 56,789,101,123. So we want to write this in scientific notation, which means we want to turn it into a smaller number because this is a very large number. Okay? So this large number is going to be turned into a small number. That means it's going to be positive because it's large. It's a big number, so it's going to have a positive exponent. You can just put plus sign to represent positive, or you can actually write positive. The second thing you're going to do is you're going to identify something called the leading digit. This is going to be the number where the decimal comes right after it. So we want to move our decimal, which our decimal is invisible, but it's right here right now at the very end. We want to move it all the way to our leading digit, which means we want to move it to the very first number. So the first number here in this expression, or this number, is 5. So that is our leading digit. That's where we want to start this number off. So it is 5. And it says, how many spaces will you move the decimal to reach your leading digit? So to get to that 5, we want to count how many spaces am I going to move this decimal. I'm going to zoom in for this. So you literally are going to make these bumps. 1 space, 2 spaces, 3 spaces, 4 spaces, 5 spaces, 6, 7, 8, 9, 10, and now I have reached my leading digit. And again, you want to make sure you counted these correctly because we're going to be using this later. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I moved it 10 spaces to the left. So I'm going to write that in. I moved it 10 spaces. So that spaces, this is going to become my exponent. So I'm basically going to rewrite my number in scientific notation. I'm going to do it down below so I have more room. And I'm just going to write 5 point, and then I write all the numbers that follow behind it. 6, 7, 8, 9, 1, 0, 1, 2, 3. Okay, so I changed it to this number. And then I'm going to always write times 10. And what's going to be different with each number that we do is the exponent. So how many spaces did we move it? We moved it 10 spaces, so that is going to be my exponent here. Okay? And we moved it to the left, so that makes our exponent positive. If we were working with a really small number, we would move it to the right, and we would make our exponent negative. But this is what we're going to do. I'm going to go through a bunch of examples. That's pretty much the process for writing numbers in scientific notation. And the purpose of doing this is it's a lot easier to work with 5.6789, whatever, than it is to work with 56 billion. Okay? Let's go ahead and move on. All right, example number 2. I have this huge number, 1 billion. So this is a big number, very big. So it's going to have a positive exponent. We'll be moving our decimal to the left. What is our leading digit? The leading digit on this number, the first number that I'm trying to move this to, is a 1. Okay? How many spaces will I move my decimal to reach that leading digit? Well, the decimal point is right at the end right now. Right? It says 0.0. And I'm going to be needing to move this 1, 2, 3, 4, 5, 6, 7, 8, 9 places. So I'm going to move this 9 spaces to reach my leading digit. And so my final answer is going to be 1.0. I do not need to include all of these zeros right here. And the reason is it's not going to change my answer. 1.0 is the same as 1.000, as the same as 1.00000. So I don't need to do that. I just need to write 1.0 times 10 to the, well, how many spaces did I move it? 9. Okay? You could also write this as just 1 times 10 to the 9th power. Okay? Make sure you have this down, and we will continue on to the next slide. All right, here you see us working with a different number. This is a very small number. This is 0.098173656. Okay, so this is a small number. It's less than 1, basically is what I mean. So it's going to have a negative exponent because we're going to be moving that decimal to the right. So this is a little bit different. To identify our leading digit, we want to figure out, well, where does the first number come into play? And when we work with scientific notation, we don't want zeros. So the first number closest to this decimal that's not a 0 is this 9. So that's where my number is going to start. That is my leading digit here. It's that 9. How many spaces do I need to move my decimal to get there? Well, I need to move it 1, 2 to get to be right behind the 9 so that that is my leading digit. So I moved it 2 spaces. So now I'm going to rewrite my number in scientific notation. I'm leading with that digit of 9. I moved my decimal point to be right behind it, and now it's 9.8173656 times 10, because that's what scientific notation is, times 10 to the, well, it had a negative exponent, and we moved it 2 spaces, so it's negative 2. We moved it back 2. So that's why our exponent is a negative 2. All right? Please make sure you have this down before we move to example 4. All right, example 4. We have this very, very, very small number. There are so many zeros here, and then it's 12 at the very end, and this is a decimal. It's not a whole number. It's a very, very small number. So is this going to have a positive or a negative exponent? It's small, so it's going to have a negative exponent. What is my leading digit? Well, what's the first number that I'm going to be moving to this decimal point to? It is this 1 right here. That is my leading digit. And how many spaces is it going to take me to get there? Let's zoom in. And this is a part you want to be really careful with, because if you get this wrong, the whole number is written wrong. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, because we want that 1 to be our leading digit. We need a number there. We can't have a 0. So I move that 16 spaces. So my new number is 1.2 times 10 to the negative 16th power because I moved it back 16 spaces. All right. Let me know if you have any questions so far. We've done 2 really big numbers, 2 really small numbers. Yeah, should make sense. It's not something that's super complicated. It's just remembering, find your leading digit, and remembering, oh, if I'm making it, if I'm moving back, it's going to be negative. If I'm moving forward, it's going to be positive exponent. Okay? All right, let's just review our new learning for today. It says we can write very large numbers in scientific notation by moving our decimal point to the left until we reach our leading digit, and then representing the number of spaces we moved by writing times 10 to the blank power. Okay? Where this exponent represents the number of spaces we moved. So for example, if I have this number, I can rewrite this with just my leading digit, and I can represent this using the number of spaces I moved as an exponent. 1, 2, 3, 4, 5, 6. Okay? We can do the same thing with very small numbers. Oops, this is supposed to say small. Cross that off and write small. I just did not write it correctly. Small numbers, by moving our decimal point to the right until we reach our leading digit, and then representing those number of spaces we moved by writing times 10 to the blank, where x represents the number of spaces we moved. So for this one, maybe we have 0.00003. This is the same as writing 3.0 times 10 to the negative, well, I moved this 1, 2, 3, 4, 5 spaces. Okay? And for both of these on here, 1.0, that's the same as saying 1 times 10 to the 6th. 3.0, that's the same as saying 3 times 10 to the negative 5th. We always want to write it as simplified as possible. So when we can eliminate even the decimal and the 0.0, we want to do that. Okay? Let's get into some practice now. All right, for this first exercise, I want you to go ahead and write all of these numbers below in scientific notation. We'll start off with this first one. Go ahead and find your leading digit. What is the first number that you're going to identify? Please type it in the chat to me. What is your leading digit here? All right, you should have identified that your leading digit is a 6. And we are going to be moving this decimal point to the left because we're making this smaller, so it's going to be a positive exponent. 1, 2, 3 spaces. So go ahead and write this number out in scientific notation. What would it be written out with a times 10 to the blank? And please check it with me. It should be 6.892 times 10 to the, it's positive exponent, we moved 3 spaces, third power. Okay? Please do this next one for me. Identify your leading digit. Count your spaces. And I want you to go ahead and write your full answer out. All right, please check it with me. It should be 1 as your leading digit, and you're moving that decimal point 1, 2, 3, 4, 5, 6, 7, 8, 9 spaces. So this is 1.239578230 times 10 to the 9th power. All right, let me know if you have any questions with that. And I'm going to have you guys go ahead and do the remaining 1, 2, 3, 4, 5 on your own. And we will check back together in 5 minutes. That's 1 minute per question. That's really, you don't even need that much time. So 5 minutes, we'll check back. Okay? All right, this first one, or the third one, see, this is your leading digit. You're moving this 1, 2, 3, 4, 5, 6, 7, 8, 9 spaces. So this is 9 point. 10 to the 9th. Okay, next one, same thing, but we're not moving as many spaces. We're doing 1, 2, 3, 4, 5, 6 spaces. This is 9.0 times 10 to the 6th. You could also write this as 9 times 10 to the 6th because you do not need that 0. Okay, next one, our leading digit is a 1. Moving this 1, 2, 3 spaces. This is 1 times 10 to the 3rd. Again, I didn't need to put 1.0 because that's the same as the number 1. F, same thing. 1, 2 spaces this time, and my leading digit is a 4. So this is 4 times 10 to the 2nd power. And then the last one here, this is just 1, 4. We're just moving 1 space. This is 4 times 10 to the 1st. This is also the same as saying 4 times 10. Is 4 times 10 40? Yeah, so you know that this is correct. We just wrote it in scientific notation. Go ahead and check those with me. Let me know if you have any questions before we move on to writing some small numbers on the next exercise. All right, we're going to be doing one of these together, and then you're going to do the rest in a breakout room. So for exercise 2, we're writing all these numbers below in scientific notation. These are all small numbers. They're all less than 1. First thing I'm going to do is identify my leading digit. Right here it is a 6. So I'm changing this to be 6.892, where 6 is my leading digit. And to do that, I need to move my decimal 1 space back. So this is times 10 to the negative 1st because I moved 1 space back. All right. Go ahead and do the rest with your group in a breakout session, and we will come back together and review them in about 5 minutes. Okay? All right, going to identify my leading digit, rewrite my number. This now becomes 1.239578230. And we're doing times 10 to the, well, I just moved it back 1 again. Next one, 9 is my leading digit. This becomes 9 point. Well, there are 1, 2, 3, 4, 5, 6, 7, 8, 9 nines, and I need to include all of them. And I'm just moving my decimal point back 1. Okay. The next one, same thing. This time though, I don't need a 0 or a point at all. This is just 9 times 10 to the negative 1st. I'm just moving this back 1. It doesn't need to be 9.0 because we're trying to write this as simple as we can. Next one, we're moving this back 1 space. This is 1 times 10 to the negative 1st. The next one, we're moving it back 1 space. This is 4 times 10 to the negative 1st. And this last one, you'll notice it's the same thing, 4 times 10 to the negative 1st, because 0.400 is the same as 0.40. Those are the same decimals. You'll notice that all of these have an exponent of negative 1. And the reason is, for every single example on this slide, we only moved back 1 space. Is that always going to be the case? No. Sometimes you're going to have zeros there. So maybe you'll have something like 0.0032, and in this case we would move it back 1, 2, 3 spaces to get to our leading digit. This would be something like 10 to the negative 1/3. Okay, check your answers with mine, make sure you have them all done correctly. Let me know if you have any questions before we move on to the next set of exercises. All right, this is just a different way of reading these questions. It says let m equal 993456789098765. Find the smallest power of 10 that will exceed m. So basically this just means write it in scientific notation. So we want to identify our leading digit, and then we want to figure out how many spaces we're moving. Okay, make sure you count them out. And then we'll rewrite our number in scientific notation. We have to include every number that they give us unless they tell us otherwise, or if those just start to become zeros forever, we don't have to include zeros. And we are moving this to the left, so it's going to be positive, and we move this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 spaces. Okay? The next one is a little bit more difficult to read because it is written as a decimal. So just for your reference, this is 78,491 and 899 out of 987. So the first thing we want to do is rewrite this as a decimal. Okay? So basically we're going to turn this part into our decimal. The beginning part stays the same. We need to figure out 899 divided by 987. What does that equal? Well, when you put that in your calculator, you should get 0.91084,093. Okay, now we have our number, and now we're going to write it in scientific notation. Here's my leading digit, and I'm going to be moving this decimal 1, 2, 3, 4 spaces. So my final number is going to be 7.84911084093 times 10 to the 4th power, because I moved it 4 spaces. Okay? Let me know if you have any questions here. Make sure you have all those numbers down correctly, and then we'll move on. Alright, we're going to get into a little bit of word problem practice here. It says the chance of you having the same DNA as another person other than an identical twin is approximately 1 in 10 trillion. 1 trillion is a 1 followed by 12 zeros. Given the fraction, express this very small number using a negative power of 10. So, 1 out of 10 trillion. If we put this into our calculator, or if we turn this into a decimal, this is a 1 in the 12 zeros spot. So 1 out of 10 trillion is going to be 12 zeros. Okay, so basically I just took this and I rewrote it as a decimal. Now I'm going to be moving this decimal point back until I reach my leading digit, which this is now becoming my leading digit. So I'm moving it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, because we need it to be on the right side, 13 spaces. So this is 1 times 10 to the negative 13th power. Okay? Next question, it says the chance of winning a big lottery prize is about 10 to the negative 8th power, and the chance of being struck by lightning on any given year is about 0.000001. Which do you have a greater chance of experiencing? So this is an example of where we would actually use scientific notation. We want to compare these two numbers, and the easiest way to compare them is to either write them both as decimals or both as scientific notation. In my opinion, it's going to be easier to just turn this number into scientific notation. So I know that this is my leading digit, so I'm trying to move this decimal to be right after it. So this is the same as moving it back 1, 2, 3, 4, 5, 6 spaces. So this is the same as 1.0 times 10 to the negative 6th. Okay? This is the same as 1.0 times 10 to the negative 8th, because 1 doesn't really change anything. So again, if it's just 1 times 10 to the negative 6, this is the same as 10 to the negative 6th. If it's just 1 times 10 to the negative 8, this is the same as 10 to the negative 8th. Which one of these is a bigger number? Well, this would be a bigger number. Even though you think, oh, well, 8's bigger, that's a negative 8, so that's actually smaller than negative 6. So which one do you have a greater chance of experiencing? Getting struck by lightning. You have a greater chance of getting struck by lightning than you do of winning a big lottery prize. Okay? Next one. It says there are about 100 million smartphones in the US. Your teacher has one smartphone. What share of US smartphones does your teacher have? Well, your teacher has 1 out of 100 million. So let's write 100 million as a number. 100 million. Okay? And now we want to turn that fraction into a decimal. So I'm going to make sure I go to the 100 millionths position. So this is my tenths, hundredths, thousandths, 10,000ths, 100,000ths, millions, 10 millionths, 100 millionths. That's my 100 millionth position. And my teacher has 1 out of those 100 millionths. So that's 1 in the 100 millionths position. So this is my decimal. Again, I got that by doing, this is my tenths, hundredths, thousands, 10,000ths, 100,000ths, millions, 10 millions, 100 millionths. Okay? Now I'm going to rewrite this in scientific notation. I'm moving this decimal place 1, 2, 3, 4, 5, 6, 7, 8 spaces. So that this now says 1 times 10 to the, well, I moved it 8 spaces back, so it's back 8 spaces, negative 8. Okay? Let me know if you have any questions there before we move on. All right, our lesson summary, don't forget this should say small. Our lesson summary today is we can write really big numbers in scientific notation by moving our decimal left until we reach our leading digit, and then writing times 10 to the blank, where that blank is our number of spaces we moved. For example, if I had this really big number, 500000321, this is the same as writing 5.00000321 times 10 to the 1, 2, 3, 4, 5, 6, 7th. Okay? We can do the same thing with really small numbers by moving our decimal point to the right till we reach our leading digit, and then it's going to be a negative exponent. So, for example, if I have 0.000312, I could rewrite this as 3.12 times, because this is my leading digit. Let's see, going back 1, 2, 3, 4, 5, 10 to the negative 5th power. Okay, let's look at what our exit ticket is going to be about today. All right, here's your exit ticket for today. The first one, you are writing this number in scientific notation. The second one, you're writing this number in scientific notation. The third number, I want you to decide if this is 10 to the 7th or 10 to the negative 7th, and you're going to explain how you know. The fourth one, Sarah said this number is bigger than this because the first number has more digits to the right than the second one. Is she correct? Explain your thinking using powers of 10. So basically it's saying compare the two numbers in scientific notation so you know which one's bigger, which one's smaller. The last one, you are ordering these numbers from least to greatest. 10 to the 5th, 10 to the negative 99th, 10 to the negative 17th, 10 to the 14th, 10 to the negative 5th, and 10 to the 30th. Okay, take your time, do your best, show your work. And when you're finished, please do the lesson reflection in Google Classroom.